Good morning, everyone. Welcome back to Natural Language Processing course. And today we will learn on Chapter 8. It is about TensorFlow. And here is the brief outline in this lecture. First of all, we will learn about the introduction to TensorFlow and what we can do with TensorFlow. Last but not least, we will see on how we can implement the program using TensorFlow. So to begin with, let's start with the first point. What is TensorFlow? TensorFlow is an open source library for performing many machine learning tasks. It provides both high-level and low-level APIs. So when we refer to high-level and low-level API here, it means that in high-level API, you can use the API more easily. You don't need to set up many tasks. But in low-level API, you will need to set up many components in order that you can use the API more efficiently. And TensorFlow, it uses a data flow graph to represent computation. So in computation here, because TensorFlow involves with many machine learning tasks, so it requires a huge amount of computations since we needs the huge amount of input data. And in TensorFlow, it uses data flow programming, which is a common programming model for parallel computing. So we have a huge amount of input data. To make the algorithm work faster, it uses the parallel computing, which means that all the computation algorithm will be executed simultaneously. And TensorFlow is basically built by Google. Many of the Google services use TensorFlow. So the word TensorFlow itself, it comes from tensor together with the word flow. Tensor basically is referring to a data. So in TensorFlow, we can run on multi-platforms, either in Linux, OS, Mac OS, Windows, or mobile device such as iOS and Android. So in addition to this, it's also run on a Raspberry Pi, which is a micro chips that we can use to perform some tasks in IoT network. So next, we will see what is Tensor. Tensor is a multinational array data, which represent the input data in the numerical format. So in TensorFlow, it uses the tensor, which is a data, and the data here, it can be in many forms. It can be in 1D tensor, or we call it to be a number. It is a scalar. We have 2D tensors, 3D tensors, and so on and so forth. So in here, when we have a specific number, it is called scalar. And if it is vectors, we have 1D tensor. So with a matrix format, it is called 2D vector, 2D tensor. So last but not least, when we have the multi-dimensional array, it is referring to tensor in this case. As we have talked about the data flow, which is used by TensorFlow. So in here, we will see the benefits of using the graph here. First of all, it gives the parallelisms. So in parallelism computations, we can run any operation parallelly, which allow our computation to be faster as much as possible. Secondly, it provides a compilation, which can generate the faster codes. As we know that for each every instructions used by the programming, which will be compiled or integrated into machine language first, so that the machine can be understood. Thirdly, it has a large community support. Many large companies use TensorFlow, such as Google, Dropbox, OpenAPI, DeepMind, so on and so forth. Fourth, it gives us the portability, which means that we can either implement it using a Python or C++ programming language. So last but not least, the main benefit of using graph, it provides distributed execution, which means that we can run the system across multiple devices or multiple specifications such as CPU or GPU. It can be work as well. So why do we need to use TensorFlow? It is an end-to-end open source platform for machine learning, and it is comprehensive, which provide many library and community resources. And for developers, they are actually easy to build and deploy their machine learning applications. In addition to this, it also provides an easy model buildings. They have a template for model construction. So you need to follow some steps which are required in TensorFlow. And next, it's also gives us a powerful experimentation for the research field. And last but not least, it can robust the machine learning production anywhere. And also, these show about the case studies of using TensorFlow. There are many larger companies which use the TensorFlow technology to improve their services and products. So next we will take a look on TensorFlow architecture. So they are provided into two parts, the front end and the core part. So in front end, it can be used either with C++ or Python. However, in the second part, it is a core TensorFlow execution. It can be run in any devices. In case that we have the higher specification, which we use GPU. So basically, GPU contains many thousands of cores compared to CPU itself. So in CPU, you have only a few cores, but in GPU, it has many of them compared to CPU itself. So concerning about the speeds and computation, GPU will give us as fast as possible compared to the CPU. In TensorFlow, it uses some modern techniques like deep learning. So in this slide, we will take a look on the differences between AI, machine learning, and deep learning. So in AI, basically stands for artificial intelligence. It gives the machine the ability to extract information from human or data so that it can model the data inputs. And next, it can try to investigate new input data. While in machine learning, it is actually a subfield of AI, which gives computers ability to learn from the input data. So by the time, it can learn more new knowledge based on the data pattern. However, in deep learning, it is actually a subfield of machine learning, which concern with algorithm inspired by structure and function of the brain called artificial neural network, or we say ANN. So in deep learning, mostly it is used for big data, big processing powers, and neural networks. So there are two categories of deep learnings. We have simple neural network and deep learning neural network. In simple neural networks, basically we have the input layer, and we have the hidden layer, and we have the output layers. So in the input layer, it represents our input data, and in the hidden layer, it requires the process on how it executes the inputs, and lastly, it provides the outputs. However, in deep learning neural network, it contains many hidden layers. So there are many structure and complex network so that it can identify the input data more accurately. And here is an example of an application in deep learning for the image processing. Suppose that they want to recognize face of a person. So there are many input data for the training here. So there are some certain steps that the algorithm needs to perform so that it can recognize an input new face. So firstly, it has the patterns of local contrast, which is extracted from the input data in the input layer. So from these steps, it's required pre-processing, which extracts some important information. And next, in the hidden layers 1 and 2, in hidden layer 1, it contains the face features. So what are face features? It's referring to some important information on a face. For example, we have the position of the nose, eyes, mouth, ears, and so on. So these are considered as face features. And from these face features, it can construct to the face in the next hidden layer. So last but not least, based on these important informations, patterns of local contrast, face feature, and the face itself, it can predict a new output layer. And next we come to how we can install TensorFlow using package manager in Python. So make sure that you upgrade PEP to the latest version. And we also require setup tools which are required in TensorFlow. And next we can start installing the TensorFlow using these commands. So this will give us the latest version, the current latest version of TensorFlow. Or you can just pipe install TensorFlow. It can also install, but it will not be the latest version. And we also need some required data sets which are used in TensorFlow for testing, for learning some model in the TensorFlow itself. We can install it via this command. It is called TensorFlow datasets. And in addition to this, we also require some additional libraries to perform matrix operations. As we know that in TensorFlow, it uses the multi-dimensional array data. So we need NumPy and Panda as well. So next we will take a look on the next point, which is what are applications, what can we do with TensorFlow. So this is the first application in TensorFlow. It is called image classification. It uses deep neural networks. So from the deep neural network here, when we have the inputs in the input layer, it requires related hidden layers, or it is called activated networks, activated neurons. And based on the activated neurons, one by one here, it can give us a more accurate data. For example, in this case, a picture is a dog. So from one layer to another layer, it tries to simplify to make it specific of the input data. So lastly, it gives us the result. It is a dog from this image. And next, we also have the cool projects which use TensorFlow to detect objects in the pictures. So in here, it refers to multi-class classification, because from the picture, we can have many objects. So from this application, it detects different objects like car, which exists in the picture. And we have the dogs standing next to the bike. And we also have the bike itself. So just to important note from here, we have discussed about the classifications. There are main three classifications. We have multi-class classification, which can detect more than one class in the picture. And we have binary classification. And the third one, we have the multi-label classification. And next, it is the application in the image processing again. It is about the color restoration in black and white photos and videos. So from the inputs, photo and videos, we have black and white, because in the past time, we may not have the digital camera. So as a result from here, we can adjust, we can restore the colors using this application. Next, it can be used in speech recognition. So as you can see that the technology has been updating increasingly so far. And we can also command, we can also ask and make a conversation with the electronic device, for example, your phone, because it requires speech recognition to perform that operations. For example, you can communicate with your device. You can say some speech and the device responds you back. So behind these, there is a technology called TensorFlow can be used to achieve this operation. In addition to the application that we have mentioned so far, the other application regarding to the text classification and text recommendation, like an application called Smart Replies, which automatically generate email response that we already have seen in the Gmail. And we have the rank. As we search information in Google, it provides us the rank of web pages based on our search query, right? So behind this, it uses the rank, which also built by TensorFlow, so that we can search the result more faster and give us the accurate one. And here are some other projects that can be used in TensorFlow. We can work on voice and sound recognitions, text-based application, image recognition, time series, and video detection as well. So next we will take a look on the last main part, which is the implementations of using TensorFlow. And this slide gives you an overview of an application in TensorFlow, which requires some certain steps. We need to import some certain libraries. So once you install the library TensorFlow, you can import it. So in here we give an alias name as TF, and from the TensorFlow we import a dataset called functions means dataset, which we can load it using this function. And next we can also prepare our input data. We have the training and test set. So in each training and test set, it has the input as well as the corresponding data, because it is from the supervised learning. Next we can initialize and configure our selected models. So from TensorFlow, we can use these to access to the Kera, which is a higher level API built in the TensorFlow, and we call to the sequential models, and then we need to provide some certain parameters. We use flatten, dense, and dropout to perform the configuration. And next, we need to compile our model using some certain other configurations, like to find some of the accuracies from the model. And next, we can train our model using the fit function. So once we have trained our model, we can evaluate our model using the evaluate functions. So some certain parameters are required in this case. Next, we will take more details on some certain codes, which is important to be used in TensorFlow. So in this example, it trains a neural network models to classify image of clothing like sneakers and shirts, which are provided from the fashion means datasets. And it uses the Kera, which is a high-level API, to build and train the models in TensorFlow. So this is how we can import certain libraries. We have the TensorFlow, and we can also import Kera using this way, or we can just actually access to Kera using the TensorFlow. We can say tf.kera. It also works the same. And we need some helper libraries to work with the matrix array multi-dimensional array data. So we have NumPy and plot here for plotting the graph. So in case that you want to check the current version of your TensorFlow, you can use these basic commands tf.version to show the current version of TensorFlow that you are using. And how we can import the function means datasets. So to load the data, you need to load it via Kera. So kera.datasets.function means. So from this function, it will return you a datasets. So next, you can prepare your data by giving the command called load data, in order that you can divide your data into the training as well as the test set. So to explore your data, whether you can know how many size of your input data, you can use this function. We call it shape. It will give you the dimension, like what is the number of row and number of column in your input data. And we can also see the size of this label, how many rows are there. Because from the dataset itself, it does not provide us a name for representing specific labels, like it is a sneaker, t-shirt, short, or pants. It just represents as the number. So in here, in codes, you may need to add some additional variables to represent these information in the strings. So in here, in order that we can display the images that exist in the training sets, we can use the plots library. So within this code, you can display the current data sets, which is the first 25 images from your training set. So here's the complete code on how you can explore your data sets, including your required libraries, loading data sets, and plotting graphs. And here are some additional examples that you can use to load the data, prepare your data for the training, and create model, train and evaluate your model. So to load the data, we have already seen from the previous one. We can, in addition to that, we can use the function load data. So in here, it will load the movie datasets. Next, you can prepare your data for training. It depends on how you divide, how you prepare your data. So in this case, we need to shuffle. We need to randomly arrange the sequence of our input data. And next, we can create and configure our model so that it can use some certain settings. And next, we can start training our models. And last but not least, we will train and try to check whether our model give higher result or not. So here's the main reference to the TensorFlow website. It is an official website, so we can get more detailed information on various functions that are available in TensorFlow. So you can visit via this URL. So in here, it provides you this how you can access to the API functions. So there are different syntax that can be used in the TensorFlow. So now we can go to the conclusion part. In the currently, many machine learning applications are needed, and they are include healthcare, recommendation engines, social media, sentiment mining, and so on. So in this case, TensorFlow is capable of achieving these goals to provide this type of applications. Actually, we also have some other application, some other libraries that can be used to perform this task, but we recommend to use TensorFlow because it is one of the technology built by the largest company, it is Google. So there are many features and large community to support us in case that we are running into trouble. So here's the homework. I hope you will learn something from this lecture, and please try to do these two homeworks which give you more information in TensorFlow. Okay, thank you.